Welcome to Mastering Solutions. This line right here represents our mirror, and they tell us that we have a barrier in between our light bulb here and this sensor, and we don't know where it is in relation to all this, but we do know that the light bulb is 70 centimeters away from the sensor here. That's the sensor, and this is 70 centimeters, or you could put 0.7 meters. They say that the light bulb is 50 centimeters away from the mirror. This distance right here is 50 centimeters or 0.5 meters. And this barrier is blocking all the light being emitted directly from the light bulb, but it doesn't block the reflected rays. And so for the sensor to see this, the light is going to come exactly halfway in between these, and it's going to reflect down to the sensor right here. And so I say it's exactly halfway because we know that the angle of incidence is exactly equal to the angle of reflection. And for the sensor to see this, if it was anything other than halfway, it would be short, or it would be too long for the sensor and it wouldn't hit it in the right spot. And so the light is being reflected halfway. Now, what is the sensor seeing, right? Well, the sensor, if it could like logically think about it, it would say, well, the light bulb is up here. That's what it would look like to the sensor. And so we need to figure out what the intensity is, and this will come into play here in a moment. To figure out intensity, let's try to remember what is the formula for intensity. I for intensity is equal to the power over the area. We know that power is going to be the 1.5 watts, and the area, that is going to be the area of this, if you imagine a giant circle. So this whole distance right here, that is the radius for the light bulb shining the light out. And so we have a large circle, and the area of a circle is pi times the radius squared, but we're not dealing with just a circle. We're looking at this as a two-dimensional image, right? But if this was a light bulb, it's shining its light everywhere. So you can think of it more like a globe. And so the area for a globe is 4 times pi r squared. So this is the formula that we're going to be using to figure out the intensity, but we ought to figure out what the radius is. And so in order for us to figure out this whole distance, it's double whatever this one here, we'll say x right here, and that's x, but this is also the exact same, that's x. So this whole distance is 2x that we're trying to solve for. So if we redraw this triangle, just so we have a clean picture to look at. So I've redrawn the triangle here. This is where the light bulb would be, of course, and this is where the angle of reflection is. And this is x, and this is x right here. So we know that this height, because the light bulb is 50 centimeters away, so this is also going to be 50 centimeters or half a meter. And since the light is getting reflected exactly halfway between the two, and we know that the distance from the light bulb to the sensor is 70 centimeters, then that means this distance here is 35 centimeters or 0.35 meters. Now we can use Pythagorean's theorem to figure out what x is, and that's a squared plus b squared is equal to c squared. We're trying to solve for the hypotenuse, which is c. So c, or we'll say x, is equal to the square root of a, which will be 0.5 squared, plus b, which we'll say is 0.35 meters squared. So when we go to our calculator, we have the square root of 0.5 squared plus 0.35 squared. And that gives us x of 0.61. So x is 0.61. But remember, we're trying to solve for 2x. That's the total path length of the light. And so if we take the answer and we multiply that by 2, that gives us 1.22 meters or 122 centimeters. So 1.22 meters or 122 centimeters. So that's the path length. And now we can come back up to our equation up here and finally solve for what we need, the intensity. So we have 1.5 watts divided by 4 times pi times the radius, which we said is 1.22 meters squared. We have 1.5 watts divided by 4 times pi times 1.22 squared. So the total intensity is 1, 2. So we'll have 8 times 10 to the negative 2 watts per meter squared. And that's the units for intensity. So this is our answer finally of the intensity for the light bulb as it is reflected off our mirror to hit the sensor.